Welcome. This is our smart water irrigation system designed for mechatronics at San Jose State University. The goal of our project was to build a hands-free irrigation system that could take care of plants without constant human supervision. It's especially helpful for people who are busy, forgetful, or just want a smarter way to care for their plants. This system monitors soil moisture and automatically waters your plants when they're dry. The main idea is to reduce water waste and ensure healthier plants by only watering when it's actually needed. Whether it's used for indoor plants, small gardens, or even educational demos, this project offers a low cost and practical solution to common plant care problems. Our system is built around the Raspberry Pi Pico, which runs all the control logic. It reads data from a soil moisture sensor to determine how wet the soil is, and if the value is too low, it triggers a relay to turn on a small pump. We also included a flow sensor between the pump and tubing to measure how much water is being delivered. This way, the system not only knows when to water, but also how much water was used during each cycle. The LCD display shows two important things: the current soil moisture percentage and the water flow rate in gallons per minute. These values update every time the pump runs. All the wiring is organized and secured inside a plastic container to keep things clean and minimize any accidental disconnections during testing. The software is written in MicroPython and is designed to be simple but effective. We start by setting up the GPIO pins for the moisture sensor, flow sensor, relay, and LCD screen. Then we define constants for what counts as dry soil and wet soil based on the sensor's raw values. In the main loop, the program reads the analog moisture value, converts it into a percentage, and compares it to its threshold, 60% in our case. If the reading is below that, it activates the pump through the relay. We use an interrupt to count pulses from the flow sensor in real time, so we can calculate how much water is being pumped. Then we use the data to compute flow in gallons per minute and display everything on the LCD. We also included error handling to deal with any LCD communication issues, which came in handy during our troubleshooting. Now we will see the system in action. Here we've placed the sensor in dry soil. The moisture percentage drops below 60, and as you can see, the relay activates the pump immediately. Water is pulled from the reservoir and pushed through the tubing toward the plant. As water flows through the system, the flow sensor sends digital pulses to the microcontroller. The software measures these pulses and converts them into a flow rate, which you can see updating in real time on the LCD display. During our testing, the system worked reliably under most conditions. It reacted correctly to changes in moisture and successfully tracked water flow using the pulse-based sensor. We did run into one challenge. Sometimes the LCD screen would freeze or fail to update in very dry conditions. This might have been caused by signal noise or a weak LCD module. Other than that, the hardware worked well, the pump operated on time, the flow sensor was accurate, and the relay switching was smooth. In conclusion, the project shows how simple hardware and code can solve a real-world problem. It's a reliable way to automate plant watering while saving water and effort. Our mission was to make irrigation smarter, and I believe we accomplished that. With some upgrades like Wi-Fi, solar power, or weatherproofing, this could easily become part of a larger smart home or garden system. Thank you for watching our presentation on the smart water irrigation system.